Hey guys, very good morning. This is Professor Reru, Assistant Professor, Department of Aerospace Engineering. For the flight dynamics class, we'll take on one of the case study, which is related to the Liftra design company, which produce a climbing crane for a wind turbine, which is installation has been done 5 times faster by using Ansys Cloud and Ansys Mechanical. So here we have the introduction about this Liftra company and the problem statement of this case study. Liftra has revolutionized the installation of wind turbines by creating the LT 1500 cranes that climbs the wind turbine tower as it is being assembled installed of setting besides it. The bottom of the crane grabs onto a flange of on tower section and lift the next section into places. Then a hose block traveled up and attached to the higher section and the pulls the crane up and the tower to attach to the higher flange. So in a sequence of such grabbing and hoisting moves, an entire wind turbine, which includes the tower, nacelle, root, blade, and other parts which is used to attaching these components. With 50 engineers working primarily in Spain and Denmark, the Liftra is developing this crane for wind turbine arms and also for end user of wind turbines to maintain wind farms. Next, we'll see the actual the company Liftra is recognized by the international wind turbine industry as a professional specialist in lifting and transportation solution of wind turbines. They guarantee excellent engineering services in this field, and all projects developed in cooperation with Liftra, it takes into account the practical context for their application. And starting out in 2003, Liftra has undergone rapid growth as a contributor and a trusted partner in the wind turbine industry. So today, this Liftra have locations in Denmark, United States of America, Spain, China, and Poland. This is the introduction part of the Liftra company, and they are doing a lot of things in installation on and the transportation of wind turbines. So now we'll go to see the Liftra company, which faces the placing of or the installation of wind turbine farms and the challenges in traditional cranes are large and expensive, which requires a fleet of tracks to move the crane to the site and between installation area of wind farm. This is a general thing. In design a small climbing, the crane that would take up less ground space and require just one track to move to the next installation site. Lifter engineers needed to able to ensure that the tower elements would not be crushed by the applied climbing force, including the loads on the towers and flanges and the grappling force. So this is the main challenge of this Liftra, which is traditional installation to the modern installation of the wind turbines. And here they use the technology of Ansys supported Ansys Cloud, Ansys Mechanical. So where the Ansys Cloud help them to design the modeling of the different parts of wind turbine, and the Ansys Mechanical helps to assemble these components, and transportation things can be done by using of designing a new crane. And they've got an engineering solution. Liftra engineers ran the finite element structural simulation both in Ansys Cloud and on their own workstations to perform static simulation of the loads involved when a crane is attached to and lifts up the long tower of the wind turbine as it is being assembled. Then ran both linear material models and non-linear material models for elastic plastic analysis for the towers to determine whether these cranes would cause us any permanent deformation to the tower, and if so, how much. The linear material model was run in the Ansys cloud on a HT vertical machine of Microsoft Azure featuring a 44 Intel Xenon Platinum and 816 process core, which is very higher and unless you have a lot of nodes and elements. This model includes 1.8 million nodes with many non-linear contacts, more than 100 frictional contacts. Using Ansys Cloud, the simulation was completed in 1 hour versus 5 hours of company workstation, which insists that the speed of 5 times of actual analysis. Now coming to this figure, first figure, the example of design where Liftra use simulations of validation, especially the holding component of the wind turbine frames. And second diagram indicate design validates thanks to simulations on and mechanical part. Finally, these are the installation of Liftra company when tower section are in the correct position. It is lower down and connected to the pre-installed tower session. And second one, these are the different blades which is installation over the top of the wind turbine and the climbing to the next position, lift and hose blocks to the outside flange of the top section. And the crane is ready to relocate of the different components. Finally, the benefit of this find element simulation confirmed that LT-1500 crane climbing the tower would not be causes any deformation of the wind turbine tower. Being able to set up this large model to run as single simulation on Ansys cloud made for a better and safe design. Instead of splitting the analysis up into multiple simulation, the calculation, the interface forces, Liftra engine were able to do everything in a same simulation. The best simulation setup was a combination of Ansys Cloud, Ansys Elastic licensing, and the Liftra its own license, which designs offer in Spain and in Denmark. It is very useful to able to borrow license and avoiding waiting until someone finishing a simulation before starting how things are new. So this is the case study of Liftra company and producing the crane design by using a Ansys cloud and Ansys mechanical. So thank you very much for watching this video and we'll have a lot of other case studies in future videos. Thank you guys. Thank you.